Good morning, dear children. We are again meeting for our online class. This is a session for students of class 12 and the subject is computer science. Now, before I start with my session, please carry your book and a pencil along with you, and by the time I am explaining the concept, just refer your book and mark all important statements, and in case if you wish, you can just make a note of important things there itself in the book. One very important thing, children, that the references to the page number or the practical implementations numbers that are given in this presentation might not tally with the numbers or the page numbers that with the book that you are carrying, but the contents are the same. So please do concentrate on the contents that we are discussing and don't get confused with the practical implementation numbers that are given or referred in this session. So please do refer your book by the time I am explaining the whole concept. So we are going to continue with the same chapter, that is data file handling, and today we would be discussing the topic relative and absolute path. And as per the edition 2021, the latest edition that you people are using, this topic is available on page number 4.18, and prior to this we have already covered the session in last class. So again, just move on to page number 4.18 as per this latest edition of the book, 2021 edition, and we are on the top of the page, that is relative and absolute path. Now, talking about relative and absolute path, first of all, let me tell you that I will be reading all the contents from your book only, and simultaneously I'll explain in case if there is anything important in that. So, talking about relative and absolute paths, files are organized into directories, which are also known as folders. Every running program has a current directory, which is the default directory for the most operations that you do in Python. That means when you are creating a file, the place where it is going to get stored, or when you are trying to access a file, from where will it come in the program, or how you are going to access it, that is all decided as per the default or the current directory that you are using. For example, while opening a file for reading, Python looks for it in the current directory. That means every time when we are working with files and we are writing programs in files, and we are referring the file names and specifying different modes to open it and using it, it actually starts fetching or searching the file content or the file from the default or the current directory. Now children, just keep underline this important statement, that is Python looks for it in the current directory. The OS module, now this is a new module, OS module, provides function for working with files and directories. OS stands for operating system. So we have a special kind of a module in Python with the name of OS module, and it deals with many functions like get, cwd, and so on, using which we can just have a look at the name of the current directory. So the second paragraph in your book says the OS module provides functions for working with files and directories. OS stands for operating system. os.getCW, that means we are trying to access a method getCW, which is a part of OS module. It returns the name of the current directory. That means if you want to see that which is the current or the default directory right now when you are using a Python or you are working in Python, you can simply make use of this method. At the interactive prompt, you can see a statement written as import OS. That means we are trying to import a module with the name OS. On the second line, again in the interactive mode only we are working, we say cwd is equal to os.getCWD function. That means whatever data we are fetching using this getCWD method or function will get stored in the variable cwd. Now you can take any other name also other than cwd. You can take a, b, c, whatever you want. And the third statement is actually printing the value that we are getting in cwd. So whatever is the current working directory, that particular directory details will be printed on the screen. Files are always stored in the current folder or directory by default. Again children, underline this statement. The operating system or the OS module of Python provides various methods to work with file and folders or directories. For using these functions, we have to import OS module in our program. That means if you want to make use of all the methods that are concerning the files and folders or the current working directory, you have to include this OS module right in the beginning of your program using import statement. CWD stands for current working directory. So just by looking at the function name, we can very easily understand that it is going to display the details or the name of the current working directory. A string like CWD that identifies a file is called a path. That means when you talk about any current working directory or any location where you are storing your data, it is actually nothing but a path. That means the place where you are actually storing your data. And in case if you are storing your data, is it right at the top, or you have created folders and subfolders and then you have stored your file. A relative path starts from the current directory, whereas absolute path starts from the topmost directory in the file system. Now this is a very important statement, please underline this. It is given on page number 4.22 and on the top. A relative path starts from the current directory, whereas absolute path starts from the topmost directory in the file system. Now the concept is same that you have seen in HTML also, in other softwares also, that in case if you are trying to fetch any data, whichever is your default directory, it will be fetched first over there and then you can access it. Now if you remember in lower classes when I taught HTML to you, and every time you were trying to make use of inserting images in your web pages, I had suggested students that please copy the image at the same place where your actual code resides, so that when you are trying to view your web page in a browser and you are trying to show an image in the page, it will start searching from the same place at the same place where your actual code is residing. So same is the case over here. So relative path means it starts from the current directory, whichever is your current directory, and absolute path defines right from the scratch or right from the beginning. So whereas an absolute path starts from the topmost directory in the file system. That means in case if you have started working in D drive and later you have created folders and subfolders and you are storing your data over there, and you want to define an absolute path, you will have to start from D:/ and then you just keep on referring the folders and the subfolders in the proper manner. For example, I am coming to the book. For example, the text file we have created in previous program was opened through the absolute path. Now, if you look at the path that is pointed by the term absolute file path, it is starting from C:/user/preeti/app_data and so on. That means we are referring our data right from the first point of its storage. That means it is stored in C drive and then followed by some folder names in a hierarchical manner. Alternatively, if I say f is equal to open and within parentheses I am just giving the name of the file, we are presuming that this file is existing at the same location from where this command is invoked. So you can say that this is a relative file path. The Python program and external file must be in the same directory, else we will need to enter the entire file path. So this is the reason why I have been reminding students again and again that you save your all data at one place, so that if you are referring any one type of data through another data, it is easier to fetch the data. The same thing is shown in the diagram also. Relative file path, your Python program, external file or the secondary storage, and then you are trying to access the data. Coming to standard file streams. Now this is important. We use file objects to work with data file, like in previous examples, in previous sessions when we were creating simple data files, we were making use of file object, and using that object we were accessing data files. Similarly, input output from standard input output devices, That means when you are talking about sending data to the output device, showing data onto the screen, or fetching data from a keyboard, they are nothing but the standard devices. So the standard devices, when I talk about input device, is considered as keyboard, and the standard output device is a monitor. So again I am reading, we use file objects to work with data files. Similarly, input-output from standard I/O devices is also performed using standard I/O stream object. Since we use high-level functions for performing input-output through keyboard and monitor, now the functions that we have already done and used, like eval or input or print, we are not required to explicitly use I/O stream object because they are automatically offered by the Python and you can just use them directly. The standard streams available in Python. Now there are three standard streams available in Python. The first one is standard input stream, the second is the standard output stream, and the third is standard error stream. These standard streams are nothing but file objects, please underline this, which get automatically connected to your program's standard devices when we start Python. That means the moment we load Python, automatically these file objects, they are automatically connected to your program's standard devices. That means keyboard and monitor in a normal case. In order to work with standard I/O stream, we need to import sys module. Now please underline this, sys module. That means whenever we are trying to get connected to the streams, we need to have this module included in our program, and for that we will simply import the sys module, writing import, which is a reserved word, and followed by the name of the module, that is sys. The method which are available for I/O operations are init are read for reading a byte at a time from keyboard, and write for writing data on a console, and that is monitor. Now this is again a very important statement. The methods which are available for I/O operations, there are two methods they are talking about. The first method is read. Method means function. For reading a byte at a time from keyboard, please underline this, this is important. And when you want to write anything onto the monitor or display anything to the monitor, we make use of a write method or write function. The three standard streams are described as follows: sys.stdin, which is for standard input, when a stream reads from standard input. sys.stdout, data written to the sys.stdout typically appears on your screen because by default the standard output is a monitor, but can be linked to a standard input of another program with a pipe. That means the output of one activity can be taken as an input for another activity. This is what is being meant by this line. Again I am repeating, data written to sys.stdout typically appears on your screen. That is, in a normal case when you are making use of this stream, the data is displayed on the monitor. But in case if there is any activity in which you want the output or the data or a result of one activity should be taken as an input for another activity, that is also possible using some pipe method. The third standard stream is sys.stderr, that is for error messages. Error messages are written to sys.stderr. So these are the three important streams that are offered by Python, and not only in Python, we see the similar concept in C and C++ also. Coming to the practical implementation, a simple program is shown to implement the standard streams. They are pretty simple. Let us see. I am talking about the code that is written on the top as the first screen on practical implementation 16. We have a comment line, program to implement standard streams. Then we have import sys, because I want to work with standard streams, so I need to include this module using import sys. The second statement of the program is f1 equal to open now. Children, please correct it. This is a mistake or a typing mistake in the book itself. The format that is used for opening a file is incorrect. You should be writing it as text.txt within double quotes, comma, and then you have to specify the mode. So please make this correction in the book. That means we are opening a data file which I presume that is already available in the current directory, and the name of the file is test.txt, and R is the mode we are using. That means I want to read data from this file. Just below it we have three statements as line 1 equal to f1.readline, line 2 equal to f1.readline, and line 3 equal to f1.readline. That means I am trying to extract individual lines of this file test.txt in line 1, line 2 and line 3. Now if I want to write or display this data onto the screen using the standard streams, then we are making use of the function write, and the way to use this is sys.stdout.write, and within parentheses I am giving line 1. Similarly, if I want to display the content of the second line, which I fetch using readlines method in the variable line 2, I would be writing sys.stdout.write and give the value as line 2 to this write method. Similarly, to display the third line, I am writing sys.stdout.write and line 3. So if you write this program with a presumption that you already have a file with the name test.txt with 3 lines in that, minimum 3 lines in that, if you run this program, you will see the data that is displayed over here as an output screen. Hello user, you are working with Python files, simple syntax of the language. So this is a simple program to show the use of a standard method of displaying data onto the screen. The lines containing the method stdout.write shall write the respective lines from the file test.txt on device. That means the standard device we are using is a monitor. So if you want to see the content of test.txt, you can simply open that file into a notepad and watch it. So it will show you the content of the file test.txt. Coming to practical implementation 17, which is a program to copy the contents of a file to another file. That means we are presuming that we have two files. We have a file and I want to copy the content of this particular file onto a new file. So let us see what program says. The first line is a comment line. Just below it I am importing OS module. Then a function with the name file copy is defined, and within this function I am using two parameters as file1 and file2, which user would be entering the name of the files later on in the main program. So let us now concentrate on this function file copy. Okay, in this function the first statement is f1 is equal to open file1 r. That means we are using a file object or a file handle with the name f1. We are opening a file with the name file1 in read mode. That means this is the file which I actually have already with me, and I would be copying the data of this file onto a new file. So another file object f2 is used to open a new file with the name file2 in w mode. Just below it, line equal to f1.readline. That means I am trying to read the line from the first file whose name is file1 and storing the content in line. That means I am trying to read the data from this file. After that we are running a loop using while loop. While line not equal to, then a blank is checked. That means we would be running this loop till the time we have accessed all the data from the file. Within this while I am using two statements. f2.writeLine, that means once the data is fetched from the file, we are writing it onto a new file which is opened using f2 file object. And you can see the comment line also just in front of it. Write the line from f1 with additional new line. Okay, and just below it I say line is equal to f1.readline. That means this process will continue. It will simply read a line from the file, write it onto the file, again read a line from a file and write it onto the file. After completing this activity, we are closing both the files using f1.close and f2.close method. So this is actually the main function that we have defined to copy the content of one file onto the another. Coming to the main program, we are saying def main. That means we are declaring main. Then file name 1 is equal to input enter the source file name. That means we are prompting the message on the screen, enter the source file name, and asking the user to enter the name of the file which is getting stored in file name 1. Just below it, we are asking the user to enter the name of the new file or the destination file, and we are storing the response in file name 2. The third is the statement which is actually a function call. We are calling a function file copy, which was defined on the top with two parameters: the first file name, that means the name of the file which I want to copy, and the second file name, that means on which I want to copy. Last statement is if underscore name equal to main. That means it is basically a check sort of a thing in which we are checking whether do we have a main function or not. In case if we have a main function, then it will be executed automatically. You don't need to call this main function, it will be executed by itself. So this is a simple program using which you are asking a user to enter a file name, presuming that file already exists, and you are copying the content of the file onto a new file, and you are accepting both the file names from the main program, sending the file names in the function, and then working on it. Just below this code you can see the output of this program. That means if you run this program, it will flash a message on the screen as enter the source file name. User is entering the name as test.txt. Enter the destination file name, and this time user has given the file name itself as file2, okay, you can take any name that you want. In this example they are taking the name as file2. So after you execute this code, automatically you will have a new file with the name file2, which will be having the contents of file1. Just below the output screen, they are showing the contents of test.txt and the content of file2 also. That means once program runs successfully, it will simply copy all the statements. Now in this case also, don't get confused. In file2, the last line is not printed. Makes Python programs easy to read and write. In fact, this line will also be copied onto the new file, that is file2. As is evident from the above output, the contents of both files are the same. That means if this program is running successfully, you will have the two files with the same content. The name of the first file is test.txt, and the other file name that user defined was file2. Coming to the last segment of this chapter, that is implementation 18. A text file named test_report.txt exists on a disk with the following contents. That means we would be using this file, and before using this file in the program, they are trying to show you the content of this file. We have a file with some data, and the data is Python is an object-oriented language. It is dynamically typed language. You do not need to declare variables before using them or declare their type. Every variable in Python is an object. Python supports two types of numbers, integers and floating point numbers, and Python is simple in syntax and understanding. So this is the content of the file that we would be using in this code. The question is, write a function capitalize underscore sentence to create a copy of test_report.txt named as file1.txt, which should convert the first letter of the file and the first alphabetic character following a full stop into uppercase. This is actually the question. That means you have to use this file and then you have to perform this conversion as given in the question. Now let us see what this code says. We are defining a function with the name capitalize underscore sentence. Inside this, f1 file object is used to open the file test_report.txt in read mode, and then we have another file object with the name f2 in which we are opening a file with the name file1.txt in w mode. Then we are running a loop while 1, that means till the time this condition is true. What we are doing is line equal to f1.readLine. That means we are reading the line from the file test_report.txt. If not line, break. Now this is basically a check performed. That means if the file is not containing any data, in that case we would be simply use break statement and come out of the loop. Otherwise what will happen? we have a comment line, strip off a new line character and any white space on the right. Now, just below it we are using one more method, rstrip. This is the explanation for this use of rstrip. That means we are trying to remove any new line character or any blank space on the right hand side of the text. For that we are making use of this function. So I say line is equal to line dot rstrip. Now this new line variable is going to store the content with chopped off extra white spaces or a new line character on the right hand side. This is the function or the use of this statement in the program. After that I am saying line length is equal to len line. That means we are trying to count the total number of characters in the length. We are trying to find out the length. Then I say str is equal to single quotes open single quotes one to concatenate all characters from the line. Concatenate means joining. Below it str is equal to str plus line 0 dot upper. We are making use of a upper function because it was given in the question that the first alphabetic character should be converted into uppercase. I is equal to 1 loop to check a line to convert uppercase, and we would be running this for length. That means till I is less than equal to line length, and then we are extracting every character using if line within square bracket I say I. We are checking every character is a full stop or not. Now in case if it is a full stop, we are adding it to the string, incrementing the value of I. That means to move on to the next line. Again we are checking have we reached the last line. In case yes, then we are breaking it down, otherwise we are converting it and then storing it. That means if you look at the code, everything is being done in str depending upon the condition. That means whether it is a full stop or we have to convert it. And finally, if you look at the last statement, outside while loop, we are writing the str using write method in f2. In file that is opened using f2 file object. Else, in case if there is any problem, print source file does not exist. That means if you are unable to find the source file, that means this else is actually working in relation with while. If you look at the indentation, it is working in relation with while. So in case if this condition is false, will directly come out of this entire process, will not be executed, and we are going to close that file. Last statement is actually the function call, that is capitalize underscore sentence. This is the main function call. The moment this statement is executed, the functions capitalized underscore sentence will get executed. Looking at the explanation in the above program, the lines from the file1 are read using read line. In order to calculate the exact length of the string, the white space or new line characters are removed using rstrip method of string library. The first character of each sentence from the file is converted to uppercase and concatenated to string str. That means we are storing it in a same variable str. That means if I say a is equal to a plus 1 and I run this statement inside a loop, so every time we are adding a value to a. Exactly in the same way, here we are simply joining the data in a str. The first character of each sentence from a file is converted to uppercase and concatenated to string str wherever full stop is encountered. So we have to check that we have encountered a full stop or not, and then we would be performing the conversion and joining of the data. Move on to the page number 4.26. Here they are showing the original file or the content of test underscore report.txt, and once the program is executed, if you look at the difference, what they are doing is every time we are encountering a full stop, it is capitalizing it. If you look at the second line of the first screen, it is a dynamically typed language, and if you look at it, it is starting with small I. But once you run a program successfully, you see that after full stop I is capitalized, so it is flashing the data as it is a dynamically typed language. So every time we encounter a full stop, the first alphabet after it is capitalized, and this was given in the question.